Hi guys, so in this video we are going to discuss about Vernier Calipers, and trust me that after completion of this video you could able to solve JEE Advanced level questions based on Vernier Calipers, right? So before starting the content, let's know why should we learn about Vernier Calipers, right? And now let us see, for example, for that question, let me have an object, right? So I don't know its length is, we don't know, just imagine we don't know length of this object, right? Now we have to measure length of this object, right? To measure length of this object, what you will do, you will use a device is called normal scale, right? Just like you will use the normal scale and then you will measure the length of this object, right? Now let us see, to measure length of this object, what you have to do, first the zero of main scale, I mean the zero of the scale should be exactly coincide with, exactly, yeah, exactly coincide with the uh, first end of the object, isn't it? So if you observe here, the first end of the object, the first end of the object was coincide with the zero of main scale, right? Then you have to check another end. So now if you observe another end, here it is 5 and it is 5.4. Let's use lens. Let's use the lens to see the value clearly. Okay, na? Let me use lens. Now let us observe the value, right? So let us zoom it somewhat more. If I zoom it more, then what you have observed here, what you have observed is, here you can decide one thing. Like for example, okay, can't write, I think so. Right? Now let us see. So here if you observe 5, 5.1, observe the readings, right? You just observe the reading. 5, this is 5, 5.1, 5.2, 5.3 and 5.4. Okay now. So here the length is not exactly like now let's once what I do, I make it coincide properly. Now let us coincide with 0 properly. Okay. Now okay, it is coinciding with 0 properly. Yeah, exactly, it is coinciding with 0 now. Now let me use once again that lens, okay, to see the readings properly, right? Now let us see. Here if you observe, the length of it is 5, 5.1, 5.2, 5.3, 5.4. If you observe exactly the length, this object did not end exactly with 5.4. It was forward to the 5.4. At the same time, this length did not reach to the 5.5. Is backward to the 5.5. So now what I can tell is, the length of this object is, the length of this object is greater than 5.4 and less than 5.5. Clear, right? So I cannot tell it is 5.4 centimeter because the length is greater than 5.4 centimeter. At the same time I cannot tell it is 5.5 centimeter because the length is less than 5.5 centimeter, right? The length is between these 2 points. Clear? Because here if you observe carefully, when you are using this normal scale, we are getting only one decimal, one digit after the decimal point in centimeters, right? Now so I can tell that the least count of this scale is 0.1 centimeter. Clear? What is the least count? 0.1 centimeter. So for this purpose, now let us see how I decided the 0.1 centimeter as the least count of this scale. First of all, what I'll take, one digit, one unit I will take on this scale. It is centimeter scale, right? Now I will take 1 centimeter. If you observe carefully, this is 1 centimeter, right? Initially it is 0 and then 1, 2, 3, 4 and 0.5. 1 2 3 4, right? 1, 0.1, 0.2, 0.3, 0.4 and 0.5, and next 0.6, 0.7, 0.8, 0.9 and it is 1 centimeter, right? If you observe carefully, 1 2 3 4 5 6 7 8 9 10, 1 centimeter, if you observe carefully, 1 centimeter we divided into 10 divisions on this scale. Okay, right? For this scale, what we have done, we have taken 1 centimeter as a 10 divisions. We divided 10 divisions. From this, if send this 10 this side, then what happens? Then like 1 by 10 centimeter is equals to 1 division, right? 1 by 10 centimeter is equals to 1 division. So if you observe carefully, from this I can tell that 1 division is equals to 1 by 10, in the sense nothing but 0.1 centimeter, right? What is this 0.1 centimeter? The 0.1 centimeter is nothing but this gap. Okay, na? This gap is called nothing but 0.1 centimeter, and it is the least count of normal square which we use. Okay, na? So now I'll use somewhat smart. I will think somewhat smart, and I'll try to get the exact value of accurate value of the length of this object. Okay, now what I will do, this gap is there, right? What is that gap? 0.1 centimeter. I'll made this into, I will divide this gap 0.1 centimeter as 10 divisions again. Understand? Now, if you observe, if you zoom it carefully, okay, now, if you zoom this carefully, okay, now what I'll do is I'll use this. Okay, so if you zoom this carefully, we no need to use scale now, right? Let me close this. You understand, right? Yeah. Now let me use this. Now what I'm going to do, is just I will take this object length. I will measure this. Let me use scale. If I use this, very good. Now let me use, now what I'm doing is just, this is the object length, right? It is in black color now. Let's use black color only, right? What it is, this is the object length. Okay, this is the 1n. If you observe carefully, this point became like, I am zooming and I'm telling this is scale. Okay, na? On the scale, this point is nothing but 5.4 centimeter, and this is nothing but 5.5 centimeter. So this is what before we discussed, right? The second end of the object forward to the 5.4 centimeter and backward to the 5.5 centimeter. So now here, this gap, whatever the gap between these 2 points, how much distance it is? It is nothing but, I told you just now, it is nothing but 0.1 centimeter. This 0.1 centimeter I will divide into 10 divisions, right? So now if I zoom it somewhat more, this is what 5.4, and this is what 5.5. Okay, na? Now what about the object? Object exactly, this is the object. Okay, now this is the length of the object. It point stop here. Now this, whatever the gap is there, I'll divide into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I successfully divided into 10 equal parts. Right now. Now, if I observe carefully, what is the length of each division? This length you have to calculate. Now what you can do, from here to here it is, from 5.24 to 5.5 it is 0.1 centimeter. This 0.1 centimeter successfully you divided into 10 divisions, right? From this, then 0.1 centimeter by 10, that is equals to 1 division. Okay, now so now what is the meaning of 0.1? It is like 0.01 centimeter is equals to 1 division. So what is here 1 division? This is small one. Now if I do this here, what I did, first I have taken normal centimeter scale and then I zoomed it. right? I zoomed it, then I got like this, again I zoomed this, and then I got like this. But is it possible in the real life? In the real life we cannot divide, we cannot zoom, right? We have scale, you cannot zoom it, and you cannot divide 10 parts between the gap of 0.1 centimeter. You cannot divide this gap into 10 divisions. That is very highly difficult. That is why we use vernier calipers. Clear? We use vernier calipers. So now here the vernier calipers least count is nothing but 0.01 centimeter. Okay, na? This is the least count of vernier calipers, right? Now let us see how does vernier calipers works, and how it works, and what is the principle that vernier calipers is working. So I hope you understand why we are going to use vernier calipers, right? Now first of all let us see stimulation of vernier calipers. Okay, now so coming to the stimulation of vernier calipers, let it open, right? To get accurate value we are using vernier calipers, isn't it now? So vernier stimulation, right now. So let us see vernier stimulation. So now here let's go with OLAPs. If you observe carefully, you have here vernier calipers. Let's use this vernier calipers. Okay now. So here this is the shape of vernier calipers. If you observe, this is called main scale. 0, 1, 2, 3. This is called Vernier's main scale, and we call it as a MSR. Okay, na? And then if you observe the small one, it can able to move. If you observe the small one, this is nothing but a movable jar. On this movable jar, you have readings, number of digits. If you observe here, readings are there, right? So this is called Vernier scale. This is called Vernier scale. Okay. Before this is called main scale and this is called Vernier scale. If you observe carefully, this is the main rule of this Vernier scale. If you observe carefully, this is 0.9, right? If it is 1 in the sense, it is 0.9. So here the 0.9, I mean how many digits are 1, 2, 3, 4, 5, 6, 7, 8, 9? 9 digits of main scale divided into 10 digits of vernier scale. Okay, na? So whenever you place the object between these two jars, then what happens? The vernier scale will move somewhat forward. Okay, na? So now what is the main thing? Let us reset it. Okay, na? Let's reset it. Then yeah. So here what is happening? The first digit of vernier scale is coinciding with the zero of main scale. That means there is no error in this vernier scale calipers. Okay, na? So one more thing you have to import, you have to note that is, let me use pen here. Okay, let me use pen here. Yeah. If you observe here, from here to here, there are 9 divisions, and here to here there are 10 divisions. These divisions are nothing but on vernier scale, and these divisions are on main scale. Okay, na? So now what if you observe carefully, you can tell that 9 divisions of main scale reading equals to the 10 divisions of vernier scale. Okay, na? 9 divisions of main scale is equal to the 10 divisions of vernier scale, right? So now from this, let's go back to the our, yeah. So if you observe, what about in the vernier calipers? What happened to the vernier calipers, right? Let's calculate here. What happened now? We have observed just now, right? So what is that we have observed there? Nine divisions of 9 divisions of main scale became equal to 10 divisions of 10 divisions of vernier scale right now. So we know very well on in vernier caliper the main scale is nothing but centimeter scale. So that one division of main scale is equals to 0.1 centimeter. Okay, na? So how many divisions are there on the main scale? Nine divisions. So 9 into each division is nothing but 0.1 centimeter. So that it is 0.1 centimeter. That is equals to 10 divisions of vernier scale. Okay, na? So now it is like 0.9 centimeter is equals to 10 divisions of vernier scale. If you send this 10 this side, then it will be like 0.9 by 10 centimeter is equals to 1 division of vernier scale. 1 division of vernier scale. So from these calculations, what we can tell, one division of 1 division of vernier scale is equals to 0.09 centimeter. 0.09 centimeter. Okay, na? So if you observe vernier scale properly, let's go back to the vernier scale. You should remember this. What is one division of main scale? One division of main scale is nothing but 0.1 centimeter. And next one division of vernier, sorry, one division of main scale is nothing but 0.1 centimeter. One division of vernier scale is nothing but 0.09 centimeter. Okay, now. So now let's back to the vernier scale, vernier calipers now. If you observe here, same thing is there now. See, 0 set. So now here, let me draw one scale here again. Okay, now let me draw one scale here. See, this is main scale. This is main scale, and it is 0, and this is vernier scale. This is also 0 only. And after, if you observe, this is nothing but 0.1, and here it is here. This is nothing but first division. Okay, na? Here this gap is nothing but how much it is. If you observe carefully, this gap is. Let me use another. Let me use yellow. Yellow, not. Let me take red. Yeah. This gap is, if you observe this gap is nothing but 0.1 centimeter, right? Coming to this gap in the vernier, how much it is? Just before we have followed, right? Just before we have discussed now, how much it is? That gap is nothing but 0.09, 0.09 centimeter. So now, if you observe carefully, this gap is nothing but 0.09 centimeter. Clear na? So now, if you subtract, there is a small gap between these two. See, for this one and for this one, right? So the small gap. This gap is called least count. Means the least count of vernier calipers is equals to one main scale division minus one vernier scale division. Okay, now what is one main scale division is called 0.1 centimeter minus what is one vernier scale division is called 0.09 centimeter. So finally you will get 0.01 centimeter. This is the least count of vernier scale. This is the least count of vernier scale. So you must know how to calculate the vernier scale. So now what happens whenever you place the object between these two jars, then what happens? This vernier scale moves forward now. While moving forward, just imagine between these two jars you kept a small like a fiber, like your brush wires are there now. You are doing while you do brush, the wires will be right. You take that wire and you keep that wire between these two jars. Now what happens? It will measure the diameter of the wire, right now. So in order to whenever you place the object between these two jars, it moves like this in this direction, right? While moving, if vernier first line, if vernier the first line coinciding with the first line of main scale, then what is meaning of this? If both two, these two are coincide, it means that the vernier scale has moved for 0.01 centimeter. Understand, right? So if the vernier scale just moved like in this direction, and the first line of vernier scale coinciding with the first line of main scale, okay now. So if these two are coinciding, it means that the gap between these two is how much? 0.01 centimeter. This is called least count now. So now when these two coincide, it means that the vernier scale has moved forward for the length of 0.01 centimeter. Then I can tell that the diameter of that wire is 0.01 centimeter. Okay now. For example, let me take one more digit here, one more digit. Let's go forward to the content, right? So this is 0.1, right? What about this? This is nothing but 0.2. Okay now. And now here this is 0.09 na? If I draw this here, one more thing, this is second line. Okay now, this is second digit, this is 2. Now this is 0.09. This is also 0.09 only. Then total how much? 0.09 plus 0.09. 0.018. Understand? If you add these two, the total length is 0.18. Now, what is this total length? 0.1 plus 0.2. I mean 0.2 only. 0.9 plus 0.9. And 0.1 plus 0.1. Then the total length is 0.2. What is 0.2? 0.2 is on the main scale. What is 0.18? It is on the vernier scale. It is on the vernier scale. So now here, just observe carefully. You kept an object between these two. Then the vernier calipers, vernier scale has moved forward. And the second, while moving forward, the second line of vernier scale coinciding with the second one of main scale. It means that now you can tell the gap between them, right? So can you guess the what is the gap between these two? This is the second one. This is one, right? The gap between these two is nothing but how here to here is 0.2. Okay, na? 0.2 minus here to here is 0.18. Now, if you do this, what happens? 0.2 minus 0.18. Then you will get like 0.02. Okay na? You'll get like 0.02. So now this gap is called 0.02 centimeter. Okay na? So if while moving the vernier calipers in this direction, if the second line is coinciding with this, then I can tell that the vernier scale has moved 0.02 centimeter forward. Then whatever the object you kept here, its diameter is 0.02 centimeter, right? This is the main principle of working of vernier calipers. This is the main principle of working of vernier calipers. Hope you understand well, right now? Hope you understand well. For example, now let's go with okay now. So now you got a least count how to calculate. What is the least count of vernier scale? Least count is goes to one main scale division minus one vernier scale division. What is one main scale division? 0.1 centimeter minus what is one vernier scale division? 0.09 centimeter. Now if you subtract this, then you will get 0.01 centimeter. Right now, this is the main working principle of vernier calipers, and least count of vernier calipers is 0.01 centimeter, right? So whenever you are calculating the least count of any vernier scale, you should first calculate how much one main scale division, and you have to calculate how much one vernier scale lives in. Then you have to subtract from both. Then you will get the least count of vernier scale. And here, the in at any time, if you want to read the reading on vernier scale, okay now, the reading on the vernier scale is nothing but main scale reading plus least count into Vernier coinciding division or Vernier coinciding point. Whatever want to use, by using this formula, you can able to measure the length of an object after, for example, 3.4 centimeter. This is we can use normal scale. If you use vernier scale 3.43, the next digit also you can able to measure successfully, right? Now let's have an object. Let's try to measure it. Okay, now let's have right now. Now what we'll do is we will take this vernier sphere between these two just and close it. Now what happened? If you observe carefully, if you observe carefully, yeah, it is quite now the sphere fixed between these two jars, right? Here, this is called main scale reading. So what is main scale reading? Came all this, right? Let me erase all. Now, now here, let us see. Let us see. First division. This is two, right? You cannot able to see right here. Let me erase everything. Let me erase here first. Yeah, right. So now here, what is main scale reading, Anna? This is 2, right? This is 1.9, 1.8, 1.7. This is 1.5. Okay, na? If you observe, this is 1.5, 1.6, 1.7. So main scale reading MSR is equals to 1.7. And next, least count already we know this 0.01 centimeter. And next, which point is coinciding here? If you observe carefully, just zoom it and watch it. You're gonna zoom it and watch it. If you watch it carefully, I can tell that first to second, the first is zero. This is zero now, and the second line is coinciding well. Then all the second line is, I mean, first on the vernier scale. Okay, na? First one is zero, second one is one na. So this first line is coinciding well. So that the coinciding point is vernier coinciding division is nothing but one. The first one is zero na, second one is one. So that one. Now what is the reading of it? Reading is equals to main scale reading. Okay na? Plus vernier calipers. I mean 0.01. Least count into 0. I mean it is a one and a how much not 0.1, you have to take one only. Okay na? You have to take one only, right? Let us take one only because the first point only coincide. Now what happens if you observe carefully? Sorry, now it is like 1.7 plus 0.01 only, so 1.71 centimeter. Now let's apply this on the vernier scale. Let's apply this on the vernier scale. You can search result here. You can search entire result here. Okay, yeah, you can find out result if you type in this way in this, then you will get the value. Okay now, so, but it may be not possible for me. You can once you can check it. Okay now, the sphere how much we got, Nana? We got like 1.71 centimeter. This is the least count. Clear now, right? So this is how we have to use vernier calipers. In the next video, we'll discuss how to uh, find out the error and how to give correction for the error, right? So hope you understand well. Now let us type here value. How much we got? 1.71 right now in centimeters. Let's check it. Yes, exactly. We got correct value right now. This is how you have to measure, use the vernier calipers. So you learned how to find out one division. So what you learned in this video, you learned how to find one main scale division. What is one main scale division? Is called 0.1 centimeter. You learned how to find out this and how to find out one vernier scale division. This is one main scale division. And you learned also how to find out one vernier scale division. How much it is? 0.09 centimeter na one vernier scale division, right? Then least count is nothing but one main scale division minus one vernier scale division. That is least count. So by using this, you could able to find out least count. After finding the least count, what you have done, how to take the measuring. This is what we learned in this video. The next video we learn about the errors. Okay, na? And we also solve a few problems. Thank you all.